To humans, this is the most important star in the universe. The Sun is the star of our solar system, providing key ingredients for life as we know it: heat for liquid water, fuel for plants, and the gravity that holds it all together. The closest planet to the Sun is also the smallest in our solar system. Mercury is only a little larger than Earth's moon. Its surface is similar to the moon, too, rocky and cratered. Mercury makes a complete orbit around the Sun, a year in Mercury time. Welcome to Venus, the hottest planet in our solar system. Its thick atmosphere traps so much heat that it creates a greenhouse effect, raising the surface temperature to around 900 degrees Fahrenheit, 465 degrees Celsius. Welcome home. Earth is our beautiful oasis in space, and its story is our story. Third planet from the Sun, warm enough for liquid water, yet protected from harmful rays and meteoroids by an atmosphere that is rich in nitrogen and oxygen. Don't forget to visit Earth's night side for evidence of human civilization: electric lights. You can also catch NASA's Hubble Space Telescope zooming by in its orbit. While moons that orbit other planets in the solar system have proper names, our moon, Earth's moon, is simply the moon. Unlike Earth, the moon does not have an atmosphere that protects it from meteorites, and evidence of impacts can be seen all over its surface. Spacecraft first explored the moon in 1959, and humans first walked on the moon in 1969. No planet has captured the human imagination quite like this one. The famous red color is the result of rusting iron minerals in the soil. Many exploratory missions have shown us that today Mars is a desert world with a thin atmosphere, but it may have had a wetter, warmer past. Welcome to Deimos, the tiny moon that moves fast. Deimos races through an orbit of Mars in just 30 hours and is smaller than Chicago, Illinois. Deimos' surface is similar to that of asteroids, but the moon's origin is still debated. It is covered in a thick layer of loose sandy ground, which can be more than 300 feet deep, created from meteorites pulverizing the surface. Despite low gravity, this could make setting down on Deimos difficult. Best to explore from space. Phobos, the larger of Mars's two moons, has orbited a rocky road around the red planet. Its surface shows evidence of thousands of meteorite impacts and one giant impact crater, the Stickney crater, that is almost half the width of the entire moon and likely came close to shattering Phobos at the time of impact. Jupiter, named for the ancient Roman king of the gods, is our solar system's king of the planets. The gas giant is second in mass only to the Sun and rules over its own small system of diverse moons, determining their geology and orbits with its powerful gravity. Storms that have lasted centuries swirl through Jupiter's hydrogen and helium atmosphere, most notably the Great Red Spot, which is about twice the size of Earth. You've reached fiery Io, the most volcanically active world in the solar system. Just as the gravity of our moon affects the Earth's tides, the powerful pull of Jupiter and its other moons push and pull on Io. Its surface is broken by hundreds of volcanoes, with some lava fountains erupting dozens of miles high. While second in size to Jupiter, Saturn holds its own iconic place in our solar system due to its striking rings. We've never seen another world quite like it. Thousands of small ringlets grouped together in 7 main rings, composed of ice and rock, which formed while dinosaurs roamed Earth. There is evidence the rings are slowly falling toward Saturn and will likely disappear in 100 million years or so. Explore them while you can. In a solar system of Roman gods, Uranus is the only planet named for a Greek deity, and that's not the only way it's unique. Nicknamed the Sideways Planet, the ice giant's 13 rings appear almost vertical because the planet itself is tilted, with its equator almost straight up and down, possibly the result of a long ago collision with an object the size of Earth. With sulfurous clouds and methane in its atmosphere, it probably doesn't smell too good here, but the methane also gives Uranus a lovely blue color. Welcome to Neptune, the solar system's beautiful blue giant, named for the Roman god of the sea. Methane in the thick atmosphere gives Neptune its color. Winds here are the strongest in the solar system, reaching more than 1,200 miles per hour, and high-pressure systems can create a prominent dark vortex, like the one you can see in the northern hemisphere. You've reached Pluto, at the edge of our solar system in the region called the Kuiper Belt. It is a small but fascinating dwarf planet, about 2/3 the width of Earth's moon. With blue skies, snow, and mountains as high as the Rockies, it may seem a little like home. But don't be fooled. When it snows on Pluto, the snow is red. Pluto also has 5 moons, with the largest, Charon, being so massive that it and Pluto actually orbit each other in a double planetary system. Welcome to our solar system, home to the Sun and all things that orbit it. That includes the Earth, other planets, asteroids, comets, and human-made objects like the James Webb Space Telescope, one of NASA's windows into systems beyond our own. The spinning collection of rocks, gas, and dust is bound in an intricate dance dominated by the Sun's gravity. The system is spread across an enormous space, making it difficult to grasp the minuscule size of planets. The spacecraft bus is the brain of the telescope. It hosts computing, communications, propulsion, and structural components. The spacecraft bus is the brain of the telescope. It hosts computing, communications. Webb's 6.5 meter, 21 foot diameter primary mirror is a gold-coated beryllium reflector used to capture faint amounts of infrared light. Webb's secondary mirror is 0.74 meters, 2.4 feet, across, made of beryllium and thinly coated in gold.
Beryllium is stiff, lightweight, and stable at very cold temperatures, but 3.4 grams, 0.12 ounces, of gold enables the mirror to efficiently reflect infrared light.
To humans, this is the most important star in the universe. The Sun is the star of our solar system, providing key ingredients for life as we know it: heat for liquid water, fuel for plants, and the gravity that holds it all together.
Welcome to the Astrea system, where you can discover and explore new worlds orbiting a star very different than our Sun. Astrea A is a smaller, dimmer red dwarf star. Because the star at the center of this system is so different from the Sun, the planets here may also be very different than those in our solar system. See what you can discover. Visit the 3 observation labs set up in this system and test out planet detecting methods. Once you have discovered new worlds, visit them to see their surfaces in detail and learn more about them in the Science tab of this menu. Some starlight is blocked when a planet passes or transits in front. Welcome to the Astrea system, where you can discover and explore new worlds orbiting a star very different than our Sun. Astrea A is a smaller, dimmer red dwarf star. Because the star at the center of this system is so different from the Sun, the planets here may also be very different than those in our solar system. Press the touchpad
See what
to
you
search
can
for
discover
planets using the
Visit
transit
the
method.
3
observation labs set up in this system and test out planet detecting methods. Planets can be directly detected orbiting a star if the star's light is blocked, similar to holding up your hand to keep sunlight out of your eyes. Astronomers use a coronagraph instrument to block a star's light and see the fainter light of orbiting planets.
Welcome to one of the trillions of galaxies that make up the universe. This immense collection of stars, dust, and gas, swirling in an enormous spiral galaxy, is one example of the complex systems the James Webb Space Telescope can study. Almost all the matter in the universe is contained in galaxies like this one. Stars are born and die as the galaxy slowly drifts through the cosmos. Beyond sight, dark matter subtly tugs on the matter we see. Each small piece of the galaxy connects with the others in some way, affecting how the system develops over time. A massive beast lurks at the heart of almost every galaxy, a supermassive black hole that silently spins and occasionally feeds on stars, gas, dust, and anything else that drifts within its event horizon. As it ingests matter, it grows ever so slightly, expanding its sphere of influence and emitting powerful jets that the Webb telescope can study. Fire stars into the vicinity of a supermassive black hole to see how it grows. Stars fill the galaxy. These twinkling points of light are a constant of the cosmos during the brief lives of humans. But stars are also individuals that live and die, growing, changing, and collapsing in varied ways depending on the amount of matter they contain. The molecules in and around these aging stars can be studied by the Webb telescope. Explore how the mass of a star affects the course of its life.
The solar mass of a star determines the age, life cycle, growth phases, and eventual collapse of the star. A star's life cycle varies depending on the amount of solar mass it has. The lifespan of a star can range from millions to trillions of years old. See the lifespans of different types of stars. The age of the star has changed dramatically. Use the controller by pressing and holding the touchpad to drag the marker on the timeline. See what the star looks like at different ages. For most of its lifespan, a star grows in size, expanding its radius. Notice how the size is measured here. The star's current phase is shown here. Continue to see how the star develops over its life. This star has run out of fuel and reached the end of its life cycle. Use your right controller to play or pause the cycle again, or travel to explore other stars.